Okay, so in a cubic function, you're going to have one real root, but since it's cubic, you have to have 3 solutions. So the other 2 have to be what? Imaginary solutions. So you're going to always have, in a cubic function, you're going to always have 3 solutions. Kai? You can. They have what they call a complex plane. We're going to get into that later on. Okay, but it's actually not a graph of the function. It's a little bit different. So we'll talk about that later on. Okay. So what are the relationships created when complex roots are expanded into standard polynomial form, and how can this help me to solve the polynomial? Those are the questions we're going to be able to answer at the end. Okay. Now, I want to ask you guys these simple questions. I mean, I can recognize the sum of 2 squares. This is something you should be able to do right now. How many of you could recognize the sum of 2 squares? It's what we just took our quiz on, right? What is an example of a sum of 2 squares? Okay, x squared plus 100 is an example of a sum of 2 squares. Okay? And I can explain why the solution to a sum of 2 squares will be 2 complex numbers. Who can explain that? Delisa. Exactly. So we would have something like this, x squared minus a negative 100, she said. And so we can factor it like what? Like a difference of 2 squares, right? And when we take the square root of a negative number, we're going to get an imaginary number. Okay, does everybody understand that? So I can explain why the solution to a sum of 2 squares will be 2 complex numbers. It's because you're going to be taking the square root of negative numbers. We got that? Okay, then the next thing right here, last question. I can explain why the product of complex conjugates results in a real number. I haven't talked about conjugates this year, but I did last year. If you remember right, we had 2 plus 4i is a complex number. What would be the conjugate? Does anybody remember this from last year? Okay. No? No, it's another complex number. Well, it's a number we can times by this complex number, and we're going to get a real number. 2. That's right there. Got it. Okay, 2 minus 4i. Oh, what's the only thing we changed right here? Yeah, the sign of the imaginary number changed, right? I want you to see what happens when we times 2 complex conjugates together. Okay? 2 times 2 is 4. 2 times negative 4i is what? Okay, negative 8i. 4i times 2 is positive 8i. You can already see what's going to happen to the i's. What's going to happen? They're going to add up to 0. And 4i times a negative 4i. What is 4i times a negative 4i? Negative 16i squared. What is I squared? It's a negative 1. I squared is a negative 1 times by a negative 16 is going to get you what? Hey, Coach Prince, how's it going? Yeah. Okay. 30 seconds. Okay, I'll be over in just a little bit. I'm going to give these guys a problem to work on for a second. Okay, these 2 add up to 0. So we have 4. And negative 16 times negative 1 is 16. That's equal to 20, which is a real number. Any questions? Okay, so when you times 2 complex numbers together, when they're conjugates, meaning that the signs are different right here, you are going to get a real number. Okay? All right, I want everybody to do this with your shoulder partner. And who doesn't have a shoulder partner? You 2 work together. You 3 do it in a circle right here. You 3 do it in a circle. With your shoulder partner, or if you have 3, I want you to just rotate it. I want you to write 2 complex conjugates other than what I've written right here. No zeros in it. No 0 plus something I, or no 4 plus 0i, or something like that. No zeros in it. I want you to write 2 complex conjugates. I want you to times them together. No, I want you to create them and give them to your partner and have them multiply them together and see if they get a real number. Okay? I'm going to give you 2 minutes to do that while I go talk to Coach Prince. Okay, you guys, now we got to move into something else right here. Okay, the next thing we have to do, you guys, is be able to recognize a sum of two cubes or a difference of two cubes. So, for instance, right here, I'm going to write this formula. Last year, we learned how to factor a sum of two cubes, and we learned how to factor a difference of two cubes. Do you remember doing this? And we had a cubed plus b cubed is equal to a plus b. This is a formula. You will want this formula on your 3x5 card for our next test. A plus b times a squared minus ab plus b squared. Okay? And for the difference of two cubes, we have a minus b times a squared plus ab plus b squared. Nope, those are correct. Okay, now, what's a small number that's a perfect cube? 4 is not a perfect cube. 8 is a perfect cube, okay? So we're gonna do this one right here. X cubed plus 8. 8 is a perfect cube, so that's a good one to use. Okay, what is the cube root of 8, everybody? 2. So we can rewrite this as x cubed plus what cubed? 2 cubed, okay? Because 8 can be written as 2 cubed, yes. 1 is 1. Oh, it's 1 also. Gotcha. Okay. 1 is also. Yeah. 1's too easy, so we went to the next one. 2 cubed. Okay. All right. So what we're going to do is we're going to use this formula to factor this, which is something we did last year. So hopefully you remember how to do it when we do this right here. X cubed plus 2 cubed. So all I'm going to do is everywhere there's an A, I'm going to replace it with what? X. And everywhere there's a B, what am I going to replace it with? Just 2. Just 2. Everywhere there's an A, I replace it with just an X. And wherever there's a B, I just replace it with a 2. See if you can do that on this first one right here. Okay, this is what you should have had. You should have had X plus 2 times X squared minus what? What goes in the middle, you guys? 2x. Some of you guys wrote x2, but 2x plus 2 squared, which is 4. Okay. Now, let me explain the difference between last year and this year, Rebecca. Watch. The difference between last year and this year is because last year, this is as far as we went. We factored it to be x plus 2 times x squared minus 2x plus 4. This year, we got to break this down. We've got to get all the roots. You'll notice that we have one real root right here because we can set x plus 2 equal to 0. And we can solve that. We're going to get x equals negative 2. That's one of our solutions. To get our other two solutions, because this is a cubic function, how many solutions does it have? 3. So the other two solutions are found in this quadratic right here. So we're going to have to solve the quadratic. Now, we know a way of solving quadratics when it's not factorable. What's that way? Quadratic formula. So we're going to take x squared minus 2x plus 4. I'm going to go over here. X squared minus 2x plus 4. We're going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There was an x plus 2, but we already solved that one. We're taking the quadratic, and we're solving that one. Because we're trying to get the other two solutions. Okay, so the question is right here, what is A, what's B, and what's C? Okay. Good. You guys didn't do the same thing I've heard every time I've taught the quadratic equation lately. Everybody, I usually get one or two people in every class say, a is x squared. Well, a is not x squared. A is the coefficient of x squared, which is 1, okay? Okay, so now we just plug in a, b, and c into the quadratic formula. And opposite of b would be what? 2. Plus or minus b squared, which would be what? Negative 2 squared is 4. Minus 4 times 1 times 4, which is 16. All over 2 times 1, which is 2. What is 4 minus 16, you guys? What does that tell us right here? Okay, we're getting two imaginary solutions because we have the square root of a negative number. Okay? You guys, we just broke down square root of negative 12 when we were reviewing for the test. What does it break down to be? 2 I root 3. Don't forget about the I. 2I root 3. So we get 2 plus or minus 2I root 3 all over 2. Yeah. You're going to say the same thing he said? 2 will go into both terms, you guys. Remember, you never can divide a 2 into a radical. So we can't ever divide it in here. But its coefficient, we can. So it's 1 plus or minus I root 3. Here are my two solutions. X equals 1 plus or minus I root 3. So if I go over here, I'm going to rewrite these two. X equals 1 plus I root 3. X equals 1 minus I root 3, right? Now I want you to see that we can write all the factors of that polynomial x squared plus 8, right? X squared plus 8. I'm going to show you what it factors down to right here. If we get everything to the left side of this equation right here, what would I have to do? X minus 1 minus I root 3 equals 0. What would the other one be? X what? Minus 1 plus I root 3 equals 0. Got it? Now, these are my factors. Take that factor, if we go back to the previous page really quickly and we look, we had one of our factors was x plus 2. Right there, we had it right here. And then this one right here broke down into those two we just wrote on the other page. And so if I go back to that page now, and I write these down, x plus 2 times x, not x, yeah, x. X minus 1 minus I root 3 times x minus 1 plus I root 3. Those three factors multiplied together would give me what? If I multiplied those all together, that would give me what? Say that again, Stephanie. It would give me x cubed plus 8. That's what we started with, right? Now, how could I multiply these together when they have all these i's in there, and all of a sudden my answer doesn't have an I in it? Because these two right here are what, you guys? No. These two are what? They're called what? What's the name for them? Huh? Conjugates. These two are conjugates, and when you times two conjugates together, you get real solutions, right? Okay. So that's why it works out that way. We would times these together, we'd get real solutions times by x plus 2. And in fact, it multiplies down to x cubed plus 8. That's pretty small, right? Now, some of you guys are saying, why? Well, x cubed plus 8 is a lot simpler than this, right? Well, we weren't trying to simplify in this case. What we're trying to do is help you understand that an x cubed function is going to have 3 solutions and how you get those solutions. That's what we're helping you. Yes? The roots. The roots are, these are the roots right here. 1 plus or minus I root 3, 1 minus I root 3, and x equals negative 2 is the other one, right? So how many real ones did we have in this? How many real roots? 1. How many imaginary? 2. Okay? We found 2 imaginary roots and 1 real root. Every cubic function has how many roots, you guys? 3. Either 3 real, or what's my other choice? 3 real, or 1 real and 2 imaginary. Okay? Kai. What's that? You come up with a lot better things than that, Kai. No. Okay, no, that's exactly right, Kai. Okay, here we go. I can explain that when solving a sum or difference of 2 cubes, one solution will be a real rational number and 2 will be complex numbers. You guys, if it is a sum or a difference of 2 cubes, everybody write this down. If it's a sum or difference of 2 cubes, 2 of the solutions are always going to be imaginary. One's going to be real. Every single time. Sum of 2 cubes or difference of 2 cubes. You're always going to get 1 real, 2 imaginary. 1 real, 2 imaginary. Every single time. Okay. This is one of the things you should be able to do. Know when to use the quadratic formula. Who can explain when you're going to know you're going to use the quadratic formula and when you're not? Say that again. When you cannot factor. That's exactly right. Hey, will all quadratic equations that you have to use the quadratic formula on have imaginary roots? No. Some will be real, but they'll be irrational numbers. They'll be real irrational numbers. But some of them will be imaginary. Okay? Next question. Comment. I can find the complex roots of a higher order polynomial in standard form. That's what you guys just did. When we took x squared plus 8, x cubed plus 8, I mean, and we solved x cubed plus 8, broke it down and found its roots, we accomplished that right there. Now, we're going to move on and find others that we're going to work on that are different than sum of 2 cubes or difference of 2 cubes, but you did that right there with that one, and we'll be doing that with others. Okay. Would you like to read the next slide? Okay. Will you please? Okay, now as I explained to Hannah just a few minutes ago, she said, do we have homework tonight? And I said, do you guys want to hear my sarcastic answer? Sorry, Hannah. All right. I told Hannah she could do one tonight, one Saturday night, one Sunday night, one Monday night, or you could do them all tonight, or all on Monday night, or all on Saturday night, or all on Sunday night. Or you can do them all right now before you leave and be done. I said what? One more thing. Right here on 8x cubed minus 64, is 8 a perfect cube? Yeah, so what's the cube root of 8x cubed? 2x. What's the cube root of 64? 4. 4 times 4 times 4 is 64. Okay? What's the cube root of 27x cubed? 3x. What's the cube root of 8? 2. So you know all of these, right? Cube root of 27 is 3. Cube root of 64 is 4. Cube root of 8 is 3. All you have to do is plug them into those two formulas, use the quadratic formula to get your two complex roots. Okay? Okay, Eli brought up a good point. Like on number 1, he said, can you just add 27 to both sides and take the cube root? You could, if all you are looking for is the one real solution, because that's all it's going to give you is x equals 3, right? Well, it's just going to give you x equals 3, but it's not going to give you two imaginary roots. So to get the imaginary roots, you have to solve it this way.